The circle graph above shows the composition by tree type of the tree inventory at Green's Nursery. So that's that right over there. The bar graph shows the average arithmetic mean height of each type of tree in the inventory. What is the average height in feet of all the trees at Green's Nursery? And this is interesting because they don't tell us how many maple we have, how many oak, how many locust, how many cherry. They just give us the percentages. So what we could do is we could take the weighted average of these means, and I'll do it once the kind of the fast way, and then I'll do it another time to kind of make sense of it, to just in case it's not intuitive how I was able to pull off the answer the first time around. So one way to think about it, let's see, the average height in feet of oak is 16 feet. So you could say that 30% of the trees are, so I'll write 30% of the trees on average are 16 feet, plus looks like cherry, 10% of the trees are on average 12 feet, so plus 10% times 12, plus looks like locust, 20% of the trees are on average 20 feet tall, so plus 20% times 20 feet. And then finally, we have 40% of the trees are on average 16 feet tall. So plus 0.4 times 16. So this right over here is going to be the weighted average of all of the trees, the weighted average tree height. So what is this going to be equal to? So 0.3 times 16, 3 times 16 is 48. So 0.3 is going to be 4.8. And then 0.1 times 12 is 1.2. 0.2 times 20 is 4, so plus 4. And then 0.4 times 16, 4 times 16 is 64, so this is going to be 6.4. And so this is going to be equal to, let's see, 4.8 plus 1.2 is 6. And then if we add the 4, that gets us to 10. And then if we add the 6.4, that gets us to 16.4. And we are done. Now, that's kind of the fast way of doing it, and it is correct. Now, if that says, hey, Sal, this looks like a little bit of voodoo. You know, you just weighted the averages by the percentages. How did this work out? Well, if you want to make it a little bit more concrete, they didn't tell us how many trees they had, but we could just make an assumption. Let's just assume they have 100 trees. Assume 100 trees. Then that means that they have 40 maple, 10 cherry, 20 locust, and 30 oak. And then you could also assume, this tells us the average, but hey, you know, that's all the information they give us. Let's just assume all of the oaks are exactly 16 feet tall. That's possible. That's their average. Let's assume all of the cherries are exactly 12 feet high. All of the locusts are exactly 20 feet high. So what is going to be the sum of all of the heights of all of the trees? Well, you're going to have 30 oaks that are 16 feet tall. So it's going to be 30 times 16. You are going to have 10 cherries that are 12 feet tall. So plus 10 cherries that are 12 feet tall. Plus you are going to have 20 locusts that are 20 feet tall. So plus 20 locusts that are 20 feet tall. And then finally, you are going to have 40 maples that are 16 feet tall. So plus 40 times 16. And then how many total trees? So this is going to be the total sum of all of the tree heights. And then how many total trees do I have right over here? Well, we just said we're assuming we have 100 trees. So we're going to divide by 100. So what is this equal to? Well, you could see pretty quickly that mathematically, I encourage you to calculate this. This becomes this exact same thing as that. If you divide 30 by 100, you get 0.3. 10 divided by 100, you get 0.1. You get 20 divided by 100, 0.2. 40 divided by 100 is 0.4. So either way you do it, you're going to get 16.4 as the average height in feet of all the trees at Green's Nursery.